Hello students, in this video we are going to discuss about combination of cells. Okay, combination of cells in series and parallel. Okay, we are going to discuss about parallel and series combination of cells, right? So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. Okay, if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. this is my Insta ID, and you can send your WhatsApp number to me for notes of this chapter. I will provide you the notes in the form of PDF. Okay, so now let's start. So now you see, suppose we have two identical, not identical, let me take different cells. So this is one cell, suppose, and its internal resistance is R1 and its EMF is E1 and internal resistance is R1. Okay, and there is another cell which is connected in series. Okay, its EMF is E2 and internal resistance is R2. So we have taken two cells in series. Okay, this is one cell and this is another cell. Okay, so hope you are getting my point. So that's how we have taken. This point is suppose X, this point is suppose Y, and this point is suppose Z, right? And potential at this point is suppose Vx, and potential at this point suppose Vy, and potential at this suppose Vz. Let me take that way. Now you see, potential difference between X and Y. Okay, potential, let me tell you one more thing here. I'm gonna explain only. Okay, so if you want to write the notes, then send your WhatsApp number, I will provide you the PDF. Okay, so don't write notes from here, because here I'm gonna explain only. I'm gonna give you the explanation only. Okay, so now you see potential difference between X and Y. Let me write this Vxy. So that will be given by Vx, potential at X, minus potential at Y, right? So now you see, as we have already discussed earlier, that in case of cell, suppose this is a resistance R and there is a cell with EMF E and internal resistance is small r, we have got the relation between the EMF and terminal velocity is equal to this terminal velocity is equal to E minus I R. We have got this relation, right? So according to that relation, that this Vxy this must be equal to E1, this is E1 minus I R1 if I current flows through this circuit, right? If I current flows through this circuit, right? Let me consider that way. So now combining these two equations, comparing these two equations, we can write that Vxy is equal to Vx minus Vy is equal to E1 minus I R1. Similarly, the potential difference between Y and Z, that is Vyz, that can be written this way, that potential at Y and potential at Z. Okay, and according to this relation, we can write that E2 minus I R2, right? So hope you have understood this. So now you see, let me copy this things, and let me copy this last two equations, and let me take a new slide. Okay, so these are the two last steps we have got, and let me copy the diagram as well. Okay, let me copy this diagram as well. So here you see, this is the diagram that we have. Okay, now you see, what is the potential difference between X and Z? Okay, so let it be Vxz, so which can be written as Vx minus Vy, sorry, not Y, Z, Vz, right? Potential at this X and potential at Z. So now you see, we can write this in this way, that Vx minus Vy plus Vy, so you can cancel this, then minus Vz, right, minus Vz. Okay, if you cancel these two, then again you're gonna get this result, right? So now this is equal to nothing but u1 minus ir1, and this is equal to e2 minus ir2, right? So that's why we can write that Vxz is equal to e1 minus ir1 plus e2 minus ir2, right? That's what we can write. Okay, so this implies that Vxz is equal to e1 plus e2 minus I is taken common, then r1 plus r2. That's what we're gonna have. Now you see, instead of two cells, suppose we have considered a single cell. Okay, single cell with EMF E equivalent and resistance R equivalent, internal resistance R equivalent, so that same current flows through it, right? Then for this circuit, we're gonna get this relation. This is suppose X point, this is suppose Z point. Okay, this is suppose Z point. So then for this equivalent circuit, we're gonna get Vxz is equal to E equivalent minus I R equivalent, right? Now if you compare these two relations, V is equal to this one, and if you compare this Vxz is equal to this one, so let me copy this and let me go to a new slide. Let me take a new slide. Okay, just wait. So here is the last two, these are the last two results, sorry. Okay, these are the last two results we have got. Just give me a second, let me write it. So now you see, from this equation, you see from these two equations, what we can do, if you compare these two equations, so E equivalent can be written as this and R equivalent will be equal to this. So that's why we can write E1 plus E2 is the E equivalent, that is the equivalent EMF, and equivalent internal resistance is R1 plus R2, right? So here we had taken only two cells. For n number of cells, that for n number of cells, E equivalent will be E1 plus E2 plus dot 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 En, right? Similarly, R equivalent will be equal to R1 plus R2 plus dot 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 up to Rn, right? For n number of cells, right? We can get this. Now let us discuss about the parallel combination. So now let me clean these things. Suppose we have two cells. Now these two are connected in parallel instead of series. Its EMF is E1, internal resistance R1. So another cell, its EMF is E2 and internal resistance is R2, right? And the potential difference between this 2 point, this potential difference between these 2 points, suppose V, the potential difference between these 2 points, suppose V, because they are connected in parallel, so terminal potential difference for both cases will be same. So here I current is being followed, so the current flows flowing through this circuit is suppose I. Let me draw an equivalent circuit, right? Instead of two cells, we have one cell. Suppose this is E equivalent and this is R equivalent. So same current is passing through this circuit, okay, and same terminal voltage. Here we have suppose same terminal potential difference, right? So in that case, now you see, so here you see, as we have two different parts here, two branches, so let the current through this be suppose I1 and through this be I2, and they add up to give I1 plus I2 is equal to I. So that's why we can write I is equal to I1 plus I2. That's what we can write. So now you see, again we have got that the relation between the terminal terminal potential difference and the EMF is given by V is equal to E1 minus I. So here I1, not I1, R1. And similarly for this cell also, we will get same terminal potential difference, because they are in parallel. Okay, in case of parallel combination, potential difference must be same, right? So that's what we have got. Now from this relation, what we're gonna get, so let me just write this way, let me write V. From this relation, what we will get that E1 is equal to V plus I R1, or you can write I1 R1 is equal to E1 minus V. So R1 will be, sorry, not R1, I1 will be equal to E1 minus V by R1. Similarly from this relation, what we're gonna get, we're gonna get I2 is equal to E2 minus V by R2. That's what we're gonna have, right? So now you see, if we put these two values of I1 and I2 in this equation, then what we will get. So let me clean these things. Now you see, let us use these two values in this equation. Then we will get I is equal to E1 minus V by R1. Instead of I1 we have put this value, and instead of I2 we're gonna put this value. So then we will get here E2 minus V by R2. That's what we will get, right? So hope you have understood this. Now you see what we are going to do here. So if we simplify this, now let me clean these things, just wait. Okay, now we can simplify this in this way. Here you see E1 by R1 minus V by R1, then plus E2 by R2 minus V by R2, and if you further simplify it, then you will get E1 by R1 plus E2 by R2, then minus V is taken common, then you're gonna get 1 by R1 plus 1 by R2. From these two terms we have taken minus V common, right? So now you see, this is gonna be equal to, if you take LCM R1 R2, then E1 R2 plus E2 R1 minus V, then R1 plus R2 by R1 into R2. That's what we're gonna have. This is equal to I. So now let us consider this equivalent circuit. Okay, so we have used here such a cell which is equivalent to these two when they are connected in parallel, right? Hope you have understood this. So in that case, so we're gonna from this circuit we will get this relation, that V is equal to E equivalent minus I into R equivalent, right? So now let me write this equation in this form. So how to write that? So let me copy these two equations and let me take a new slide, okay, so that I can explain clearly. So here is the one equation, and another equation from the equivalent circuit is this. So this is the equation we have got from the equivalent circuit. Now you see, if you simplify this, then what you gonna get from this equation? Let's obtain V. So then V is equal to R1 plus R2 by R1 into R2 is equal to E1 R2 plus E2 R1 by R1 into R2 minus I. That's what we're gonna get. Then V will be equal to E1 R2 plus E2 R1 by here we're gonna get R1 plus R2 minus I into R1 R2 by R1 plus R2, right? Just simple simplification. What we have done, we have multiplied both the side by reciprocal of this term. That's it, right? Hope you have understood this. So now if you compare these two equations, this one and this one, then what you will get? Now let me clean this above equations. So now here you see, if you compare these two, you can compare this one with this E equivalent, and you can compare this one with R equivalent. Then E equivalent will be equal to E1 R2 plus E2 R1 by R1 plus R2, and R equivalent will be equal to R1 R2 by R1 plus R2, right? And similarly this one can be written this way also. R equivalent is equal to 1 by R1 plus R2 by R1 into R2, which is equal to 1 by R1 plus 1 by R2, right? That's what we will get. So now you see, if you obtain the ratio of these two, then what you will get? If you obtain the ratio of R equivalent by E equivalent by R equivalent, then these two denominator, sorry, not this one, okay, so this is supposed to be plus here, you see, these two denominators will be cancelled, right? So then what we can have, then E1 R2 plus E2 R1 by sorry, not R1, then we will get R1 into R2, right? Now you see, this is what we have got, and this can be written this way also. E equivalent is equal to, now this can be simplified this way, E1 by R1 plus E2 by R2, because you see, you can write this way, E1 R2 by R1 R2 plus E2 R1 by R2 R1 R2. So here R1 R1 cancel, here R2 R2 cancel, then you will get this. So hope you know these things. These are very simple things, just simplification. So now you see, that's what we will get. So this is for only two cells. One more thing, this R equivalent, I forgot to write this R equivalent, it can be written here, right? So now you see, similarly for n number of cells, you can write E equivalent is equal to E1 by R1 plus E2 by R2 plus dot 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 En by Rn into R equivalent, right? We can write this. Similarly for n number of cells also we can write this 1 by R equivalent equal to this one plus 1 by Rn, right? We can write that way. So hope you have understood this. So thank you for watching. See you in the next video. In the next part we're going to discuss about Kirchhoff's law and Wheatstone bridge. Stay connected.